What we are here to talk about is Ubuntu genAI technology. Ubuntu genAI is a major breakthrough in artificial intelligence. By exposing the spirit of Ubuntu as a reduced order model, then finding the evolution of the collective as geodesic motion, Ubuntu genAI reduces the energy and data required by factors of 100 million, thereby significantly decreasing the cost and improving the performance of AI. Ubuntu genAI achieves these efficiencies by having a formula for a functional transformation instead of searching a Banach space for a functional, that is, fitting a universal functional approximator or deep convolutional neural network. And by finding the geodesics as minimal surfaces with a simple few thousand parameter multi-layer perceptron with rectified linear unit, activation in an autoencoder geometry. Multi-layer perceptrons with rectified linear units are piecewise linear universal function approximators, especially well suited to finding minimal surfaces with a limited number of cusp-like singularities. Minimal surfaces can be represented by an analytic function or field or topology specified by f of z or capital H of beta. Ubuntu genAI unlocks significant value by the characterization, optimization, and control of topology. In summary, Ubuntu genAI has a predetermined formula for a functional, not a trillion parameter deep convolutional neural network. It has a simple MLP with ReLU autoencoder with only thousands of parameters. It determines an analytic function or topology specified by f of z or capital H of beta. Therefore, Ubuntu genAI uses 100 million times less energy and requires 100 million times less data. It has significantly lower costs and better performance, like the human brain. Another way of looking at the transformation from the individual or reduced order model to the collective or field is as a multiple reflection of the puppets controlled by the puppet master according to a geodesic motion by a hall of mirrors. This is demonstrated by the mirror maze scene from the 1928 Charlie Chaplin movie The Circus. You see one of the puppets, Charlie Chaplin, moving around and being multiply reflected, giving what looks like a crowd of people moving around. Then there is an introduction of a second puppet, so that the crowd is now made up of two puppets controlled by the puppet master, multiply reflected through the hall of mirrors. A practical way of understanding the breakthrough that is Ubuntu genAI is starting with an examination of the structure of current generative artificial intelligence, genAI, exemplified by David Silver's DeepQ networks, Google's DeepMind tech, and Alex Radford's generative pre-trained transformers, OpenAI's ChatGPT tech. Both are deep convolutional neural networks, deep CNNs, and iterative convolution with a bank of wavelets, and iterative wavelet transformation, interleaved with an activation function or rectifier that is usually a rectified linear unit found by some to be the log modulus. This is a universal functional approximator with the structure of an autoencoder, yielding a reduced order model. Canonical coordinates that are generated by a generating function that is the solution to the Hamilton-Jacobi-Bellman equation. Furthermore, the deep CNN approximates the generating function of the canonical coordinates with a symplectic geometrical structure that is the solution to the Hamilton-Jacobi-Bellman equation. This generating function, that is action, is the approximate score function of GPTs and the approximate value function, that is the approximate Q function of deep Q networks. The approximation parameters are half of the reduced order model, the canonical momentums or co-states. Note that a functional takes as an input a state expressed as a function, then outputs a function. Unfortunately, it takes more than 1 trillion parameters to approximate a functional, and even with this many parameters, assumptions are made that constrain the solution away from the desired functional. Once this functional transformation is found, the state can be expressed in a handful of parameters: the reduced order model, or the navigational waypoints, or topological indices, or quantum numbers. The evolution of the system can now be described by an analytic function, a simple, very flat, minimal surface that can be well described by a piecewise linear universal function approximator with only thousands of parameters, such as a multi-layer perceptron with ReLU activation, the action function or generating function of the evolution. Meanwhile, there has been an outstanding problem in physics to unify the four forces, the holy grail of physics, a grand unification theory. Currently, there is the standard model of Murray-Gell-Mann that unifies 3 of the forces, but not gravity. The fundamental roadblock is not having an analytic formula for renormalization. That is, the reduced order model or canonical coordinates that are generated by the solution to the Hamilton-Jacobi-Bellman equation or renormalization group equations from the path, that is, the state of the field expressed as a function. There also has been a missing analytical tool for topology that transforms a path, a cycle expressed as a function, to the reduced order model or topological indices. Obviously, generative artificial intelligence is approximating the needed renormalization functional transformation and is approximating the needed topological functional transformation. The form of the GPTs and DeepQ networks give a clue as to the analytical form of the functional transformation, a formula for the functional transformation, like the formula for the Fourier transform. In this case, it is a localized Fourier transformation. This is analogous to how the mold penicillin gave a clue to the molecular structure of antibiotics. The breakthrough came when we realized that the formula for the functional, the solution to the computational AI, physics, and mathematical topology problems is given by an invertible and fast discrete wavelet transformation interleaved with the log z analytic function. This formula can then be proven by induction, and the analytic rectifier, that is big R of z, is equal to I log of R naught of z, which is equal to big G of z, where the R naught of z function is like the 1 plus x function for the log absolute value of 1 plus x. It's identified as the well-known analytic Green's function. Furthermore, the formula can be identified as the m-body Green's functions, the S matrix, that is the m-body scattering cross sections, or the Wigner-Weil transformation. We have called the formula for the functional transformation the Heisenberg scattering transformation because Werner Heisenberg proposed the scattering matrix approach to field theory. This breakthrough eliminates the need for the trillion parameter deep convolutional network so that all that remains is a few thousand multi-layer perceptron. Note that the canonical structure of physics is isomorphic to the mathematics of economics, so that this is also a breakthrough in economics and finance that leads to the investment and trading applications of Ubuntu genAI. So, the HST is a fundamental breakthrough in computation, physics, mathematics, specifically topology, and economics. Also note, the Hamilton-Jacobi-Belmont equation is called the Hamilton-Jacobi equation in the physics literature, and the Belmont equation in the computational AI literature, specifically the deep Q network literature, and the systems control literature. The essence of my breakthrough was realizing that the transformation could be separated into a problem that is physics or application independent part and a much smaller problem dependent part. Then I realized that a formula with a very fast, that is n log n scaling, computer valuation, and inverse evaluation could replace the trillion parameter deep CNN approximator of the very large problem independent part. This transformation is an analytic way of evaluating Jim Simon's topological indices and Werner Heisenberg's S matrix. Jim Simons proposed the Chern-Simons form in 1974, and Werner Heisenberg proposed the canonical or matrix approach to quantum mechanics and field theory in 1943, and it was refined by Lev Landau in 1959. The S matrix is simply the matrix of n-body scattering cross-sections. This is why I called my equation for the transformation the Heisenberg scattering transformation, the HST. It is a transformation to Heisenberg's S matrix basis. It is new mathematics, new physics, new economics, and new AI. Why did we use this word Ubuntu? The HST calculates the localized Fourier spectrums of the collective system that emanates from the interconnectedness of the collective. The spirit of Ubuntu social philosophy provides the interconnectedness that coordinates, links, and holds society together. This is why we call our new AI Ubuntu genAI. It is AI that generates the interconnectedness of the collective, like the spirit of Ubuntu. AI is about model estimation. Many times estimation of a transformation to and from a space where the solution of the problem is trivial. The model or transformation is a mathematical expression with free parameters that need to be estimated using data. To have a reasonable statistical estimation, the number of data points should be about 30 times the number of free parameters in the model. 30 points per parameter leads to a statistical estimation of the parameters with about 18% relative error. For example, to estimate a line which has 2 free parameters, one needs about 60 data points. To estimate a piecewise linear expression with 10 segments and 22 parameters, one needs about 660 data points. To estimate a functional transformation like the Fourier transform or the HST, today's generation of AI uses a model with 1 trillion parameters that needs about 30 trillion data points to fit it. Even 1 trillion parameters are not nearly enough, so that assumptions need to be made in the form of the model that significantly constrain the estimation of the model away from the true underlying model. This computational task of fitting 1 trillion parameters is massive, using up to $1 billion of energy, enough energy to satisfy the energy needs of the U.S. for 10 days. The HST is an exact analytic equation for the model that is the transformation with no free parameters. Therefore, no data is needed and a trivial amount of computation needs to be done. The equation simply needs to be evaluated. This slide shows a way of visualizing an estimation of the y equals sin x model using a piecewise linear expression with 5 segments. Shown is the model equivalent to the HST. The data used to fit the piecewise linear expression with 5 segments, equivalent to an MLP with ReLU activation, one hidden layer with 5 nodes. The optimal MLP estimation and a zero-dimensional estimator with 1 parameter equivalent to the GPT estimation of a large language model. The effect of the dimensional limitation of the constraints imposed on the GPT estimator is illustrated by limiting the MLP estimator of a one-dimensional surface to 0 dimensions. The limitation imposed on the GPT estimator is exponentially worse. The MLP is limited to a fractal dimension of 1/2, while the GPT is limited to a fractal dimension of 1/1000. This is the difference between a magnitude 2 earthquake and a magnitude 1000 earthquake, where a magnitude 3 earthquake barely shakes your dishes and a magnitude 9 earthquake turns an entire city into a pile of rubble. AI is about model estimation, many times estimation of a transformation to and from a space where the solution of the problem is trivial. Currently, the generative pre-trained transformer architecture estimates the functional transformation and estimates the trivial generating function, a minimal surface in the transform domain, together, specific for an application. The functional transformation is approximated with a deep convolutional neural network in an autoencoder geometry, and the generating function is approximated with a multilayer perceptron with rectified linear unit activation. integrated into the deep convolutional neural networks architecture. It is the functional transformation transformer part that are pre-trained in a GPT, since they are not application specific. Unfortunately, the functional transformation part is not isolated from the generating function part in a GPT, so that the pre-training cannot be effectively done nor identified. Ubuntu genAI separates the problem into an application-independent part for the functional transformation, for which it has a zero-parameter analytic formula, that is myHST formula, instead of a trillion-parameter deep CNN estimator, and an application-dependent part for the analytic, that is minimal surface, generating function, for which it has a 1,000-parameter MLP with ReLU activation estimator. The result is a controller of collective systems from a measurement-based characterization of collective system. The input to the controller is a measurement of the collective field, and the output from the collective controller is a force field that controls the system. The controller guides the collective system to stable and sustainable optimum performance. The circuitry of the functional transformation is most likely found in the primary visual cortex of the brain, and the circuitry of the Hamilton-Jacobi-Belmont solver is most likely found in the prefrontal cortex of the brain. Now on to a mathematically concise and precise description of this new theory. The new theory of collective behavior, that is, swarms of interacting entities, whether that be elementary particles, charged particles, molecules, celestial bodies, or economic entities, is made up of two parts that are really the same. It is a mapping of the collective state, that is, transformation, to a domain where the dynamical evolution of the collective is trivial, that is, motion in a straight line at a constant velocity, also known as linear or force-free motion. This also can be viewed as geodesic motion on the dynamical manifold. First, the transformation is a functional transformation from the domain of the conjugate field momentum and field to the domain of the conjugate momentum and coordinate little p and q. This functional transformation is generated by the generating functional, big S sub little p, a functional of the function f of x. In the domain of little p and q, the dynamical evolution is restricted to a low, finite dimensional, complex linear subspace, but the evolution is nonlinear in this subspace. This transformation is also known as the Wigner-Weil transformation or the Heisenberg scattering transformation. The second transformation is a transformation from the domain of the conjugate momentum and coordinate little p and q to the domain of the conjugate momentum and coordinate big P of q. This canonical transformation is generated by the generating function big S sub big P of q. This transformation is constructed so that the dynamical evolution in the big P and q domain will be linear, that is, evolution along a straight line at a constant velocity, specified by d big P with respect to dt equals 0 and d big Q dt equal to a constant, that is the partial with respect to the energy as a function of big P with respect to big P. It can be shown that the generating function big S sub big P of Q satisfies the Hamilton-Jacobi equation, also known as the Bellman equation. The generating function is also known as the log likelihood, the entropy, the action, the Q function, the score function, or the value function. Both the generating functional, big S sub little p functional of the function f of x, and the generating function, big S sub big P of Q, can be specified by their Taylor expansion coefficients, which are the same. The Taylor expansion coefficients are also known as the S matrix, the M-body scattering cross-sections, or the M-body Green's function. What is generated in Ubuntu genAI is the dynamical evolution of the collective, or an ensemble of the collective's dynamical equilibrium in big Q at constant big P, where the probability of the state is given by an arbitrary probability function in terms of big P, d big P, d big Q. This is in contrast to generating an ensemble of a collective in thermal equilibrium with an external system or heat bath of temperature big T. In this case, the distribution is a Boltzmann or thermal equilibrium distribution in big P and big Q, where the probability function of big P is equal to e to the minus energy with respect to big P divided by the Boltzmann constant times the temperature big T. The current theory of generative AI believes that the system is in thermal equilibrium and believes that it is generating a statistical ensemble from a thermal equilibrium distribution. Now, what are the AI questions? Like deep thought, there are two questions. The first and most important question is, what is the ultimate question? The second and subordinate question is, what is the answer to the ultimate question? The most important AI question is, what is artificial intelligence? The answer is the characterization, control, and stabilization of collectives. The subordinate AI question is, what is inside the AI black box that does this? The answer is model estimation. For the first question, what is artificial intelligence? At a high level, the B&Z energy innovation is the characterization, control, that is friction-free investment or optimization, and stabilization, that is arbitrage trading or lubrication of collective systems, using topology and a new theory of the physics of collectives or fields. Collectives are fields or swarms of elementary particles, charged particles, molecules, celestial bodies, economic entities, and so on. Deep generative AI done right is the characterization, control, and stabilization of collectives, instead of resorting to the addition of dissipation, that is, friction or interest. This AI-enabled control is like the active control of an F-16 fighter, except for a collective system. Instead of applying a force field is applied. This has been a grand challenge of physics, mathematics, computer science, economics, and finance. The business, economic, scientific, and engineering impacts are breathtaking. This one advancement leads to breakthroughs that enable fusion energy generation, topological quantum computers, financing of long-term capital investments like green energy and healthcare, friction-free business and economic investment and trading that is vastly superior, think dollar signs, to existing interest-based methods, jet engine mufflers, commercial supersonic flight, the grand unified theory of fields, true innovative and creative artificial intelligence, weather control, for example, rainmaking, and so on. The key two words are collective and control. That is, control of a collective that is a complex system. I realized this in August of 2023 when I was reviewing on the back portal of my home in Santa Fe the lectures on deep reinforcement learning for a graduate course in machine and deep learning that I had recently taken at Carnegie Mellon University, the book Neurodynamic Programming, and the book Fundamental Methods of Mathematical Economics. It became apparent that deep reinforcement learning assumed that one had a Hamiltonian system that one controlled through dynamic programming based on the Hamilton-Jacobi-Bellman equation, and that economics also assumed that the economy was a Hamiltonian system that one should control through dynamic programming based on the Hamilton-Jacobi-Bellman equation. They are both questions of systems control. Both deep reinforcement learning and economics correctly optimize the action, the approximate Q function, in the case of deep reinforcement learning, and the value function in the case of economics. Unfortunately, both deep reinforcement learning and economics, instead of using active control, added a resistivity term to the Hamilton-Jacobi-Bellman equation to both stabilize the solution and control the system. They both also incorrectly specified the Hamiltonian of the system because of the addition of resistivity. Immediate engagement or short-term exploitation instead of sustainable activity or long-term social good in the case of deep reinforcement learning, and the discounted free cash flow instead of revenue or gross domestic product in the case of economics. Now let's focus on the second word, collective. About a week later, I was sitting at the breakfast table of my home in Santa Fe, having my morning coffee, when I had a second epiphany that both deep reinforcement learning and economics were a question not of control of a Hamiltonian system, but control of a collective system or Hamiltonian field. The subject that I received my PhD in theoretical physics for studying and researching. This is the reason that deep convolutional neural networks were introduced into deep reinforcement learning to study a system whose state is specified by a function or field, f of x, and conjugate field momentum, pi of x, instead of a coordinate q and conjugate momentum, p. An economy is also a collective of economic entities. The key missing ingredient is the formula for the functional transformation from the space of the conjugate field momentum and field to the conjugate momentum and coordinate little p and q, also known as the reduced order model, where the Hamilton-Jacobi equation can be solved for the action or generating function of a canonical transformation to coordinates big P and Q, where the motion is along a straight line at a constant velocity. My formula for the Heisenberg scattering transformation, or Heisenberg's S matrix. At a symposium at the Flatiron Institute in November of 2023, I realized that generative pre-trained transformers were also using a deep convolutional neural network to transform from the field domain to the reduced order model, then solving the Hamilton-Jacobi-Bellman equation for the action, which was called the approximate score function in this case. So, the problem that is solved by my Ubuntu genAI is how to control a collective. AI is collective control. On to the secondary question. What's inside this AI black box that does this anyway? Simply stated, the technical breakthrough is replacing the trillion parameter fit of a deep convolutional neural network with a formula with no parameters based on topology and the physics of collectives or fields. I am a very rare commodity as a theoretical physicist, both skilled at topology and the analytical theory of collectives. This has allowed me to make the technical breakthrough where others have not been able. Let's discuss one of the most impactful applications of Ubuntu genAI that BNZ Energy will address: fusion energy generation. There are two roadblocks to achieving up to 2 gigajoule yields, more than enough to make a practical field fusion reactor with 2 megajoules to 10 megajoules of input energy, and input energy currently available, driven by either pulse power or lasers. 1, determining the knot to tie in the plasma, and 2, knowing how to tie the knot in the plasma. Ubuntu genAI breaks through these roadblocks, reducing the design of a fusion power plant to a 3 to 5 year development project. Ubuntu genAI does this by forming a helical tornado with a compact twisted pair that is not at its core, where the fusion reaction will take place. Especially for non-inertial fusion energy generation, there is a third roadblock that Ubuntu genAI breaks through, stabilizing the knot in the plasma into a compact structure that does not disrupt. The value of Ubuntu genAI comes from controlling the system, the plasma. We have published in a refereed scientific journal a proof of concept that is a numerical experiment or benchmark of Ubuntu genAI applied to this very sparse and high-dimensional application. It demonstrated that Ubuntu genAI was trained in 20 core seconds to simulate the 2D plasma in 1 core second, a task that would take 240 core hours using existing technology. In 3D, it would take more than 100,000 core hours to simulate using existing technology. Given this, Ubuntu genAI Simulator, the fusion target and drive design can now be optimized and the implosion stabilized. There's nothing special about fusion energy generation. This is a general proof of concept of AI control and stabilization of high-dimensional collective systems. Here are the results of the fusion benchmark. Note that Ubuntu genAI performs near the theoretical limits, while both AI 1.0 and 2.0 are many orders of magnitude, like 10, from their theoretical limits. These are large differences, like for earthquakes. A magnitude 3 earthquake barely shakes your dishes. A magnitude 9 earthquake turns an entire city into a pile of rubble. Therefore, Ubuntu genAI is much better, cheaper, and more applicable. Here are the links to the YouTube videos and technical papers with the details of Ubuntu GenAI technology. First, a TED-like talk. Second, the new physics theory. And third, the new economic theory. There are also links to details of the fusion energy generation, application, and benchmark, along with details of the Heisenberg scattering transformation. Thank you for your attention.